All right. We're going to go all down through the list. First, if I decrease the pH, what happens to my hydrogen? Can we hear from? What happens to our hydrogen? It'll increase. So then our hydroxide has to do what? Mark. Okay. No. They always do opposite things. And the solution is now more what? Can we hear from?
Soluble.
The solution becomes more basic.
False.
That's so acidic.
More acidic. If it is bigger, it is more acidic. Basic. If it is smaller, it is more acidic. Go and flip over to page 29. There are a couple notes. First, at the very top, please capture these three formulas. You'll need these three formulas. Please put them above. On the top where they are indicated here, you should have this arrow already. These two go above the arrow. This goes below the arrow. Again, these belong exactly where they are relative to the arrow. These two go above, this one goes below. Once you've annotated all three of these, pull out your tiny table. So that star circle highlight these on your tiny table. This is a negative sign. I made it nice and big so we don't forget it all the time.
Is that a positive sign?
Yes, that is a negative sign. It's very big so you don't forget about it.
What is log?
That's a negative. Log stands for logarithm.
This is already
Or logarithm. On your tiny table, once you've annotated these three, back side, right side where it says solutions. Angel. We already know about the molarity calculation. The two that are black, Jacob, Eric. The two that are black, you should star, they're already listed. The one that is green is not on here, you should add it. Okay, throw the trash away. Here, it's in here too. Throw the trash away. The one in your hand right there.
Can you help me carry this?
Okay, put it away. You're editing. 1, 2, 3. 15 more seconds. We're annotating on the one you're missing. Star, circle, highlighting. You will not be able to use your packet for your quiz. Make sure you know where these are on your tiny table. Yes. Yeah. 12 more seconds. You are not looking at your tiny table. You are not on task. Back side, right side, under solutions. You should have starred the two that are there, sub their head up, and you should have added on the one that's in green. Libby, Gabriel. Look for it. 6 more seconds. You should have starred, circle, highlighted the black formulas, added on the green one. And then back on question 1. Take 2 seconds to annotate. What are they giving us? What do they ask us for? To annotate question 1, can we hear from?
Alonso.
So what are they giving us? What are they asking for?
They're asking us for pH. That's it, right? I don't do that, or
What are they giving us?
they give us the hydrogen ion concentration.
Libby, settle their heads up. Last reminder. All right, so this is part of the way we put it on the top the way we did. They give us hydrogen. We are asking for pH. So find hydrogen. on that top right corner, under the big old arrows. They give us hydrogen. To go from the hydrogen side to the pH side, what's the formula we use? Yep, our log formula. pH is the negative log of our hydrogen. So those of you in Algebra 2, this is the logarithmic work you've been doing the whole year for the past couple of weeks. Those of you who just geometry, you're like, why are there trees? Because they're next to you, it's okay. In your calculator then, you should enter negative log. When you populate the log button, it will create 2 parentheses. We assume this is base 10, so we can just leave this one alone. I want to put the hydrogen concentration here. So I put 1.3. How do I do times 10? The east end button, extended exponent. So east end, negative 5. This should get you positive 4 point stuff. Positive 4 point stuff, make sure you write it to the 10th place, 10th. The hardest part is the calculator part. Make sure you're pushing the buttons, practicing the calculator portion. That is where folks go wrong. It should be positive 4 point stuff. If you get a negative number, you forgot the negative in the beginning. You cannot have a negative pH, it would not make sense. O the universe acid. That'd be weird. Positive 4 point stuff. Rounding to the 10th place. You can just leave it alone, because it'll default to next time. Libby, Gabriel, you're plugging this into your calculator. You're rounding it to the 10th place on your page 39.
What do we put in for 8?
The hydrogen.
Oh, well, yeah.
You should get positive 4 point stuff. You should get positive because you should have a negative beginning. For our pH, can we hear from? Arlen, what do we end up with? There's no unit for pH, which is not satisfying. And then would this be acidic, basic, or neutral? It is acidic, it is less than 7. Drop on to question 2. What are they giving us? What are they asking us for? To annotate question 2, who do we hear from?
Stephanie.
And then what do they want? So they give us pH, they ask us for hydrogen. So look at the top. There are 2 different formulas we could use. We have pH, we're looking for the hydrogen. Do we need to talk about hydroxide here? Do they talk about hydroxide?
Yeah.
So then I don't want that KW formula, because I don't need hydroxide, I just want the other guy. So hydrogen is 10 to the negative pH. So in your calculator, I put 10. This little caret button populates the exponent, little exponent box. And then I'll put negative 11. That should get you 1e stuff. If it gets you a crazy fraction, hit Control Enter, it should give you a decimal.
Yeah, I have a question. You know how you said about hydrogen hydroxide? But it
They want to know the more concentration, but we don't need the number for hydroxide. We just know what they're getting more. They want hydrogen? Yeah. We'll see a question in a second when they ask for hydroxide. You want these, so then write it. Once you get that number, write it like a human. You are a human, not a calculator. Your answer should not have an E in it. The unit here is molarity, because it's the concentration. For that number, can we hear from?
Ozzy.
Big friend. What does the E represent? And the unit here again is molarity, it's a concentration. And then take a second, deciding if this is hydrogen or hydroxide. What is there more of in this substance? Some of them. What do we have more of? Can we hear from?
Daniela.
Daniela, I don't know what I was hearing.
Hydrogen.
Is this an acid or a base?
It's a base.
So then there's a lot more of the hydroxide. Acids have all that hydrogen in the beginning, bases have a lot more of that hydroxide.
Oh.
Drop on to question 3, this is a weird one. Are they giving us, what are they asking you? This is a weird one.
You gotta work backwards, guys.
Sort of. Once we finish this. All right, to annotate number 3, can we hear from?
No.
Hydrogen ion concentration.
They give us the hydrogen. What do they ask us for?
We use KW.
What do they want?
What is the hydroxide
Ah,
concentration?
we only have one formula that uses hydroxide. That's that KW formula. So whenever they talk about hydroxide, I will need this formula. So KW is hydrogen times hydroxide. This looks terrible, but it's really just A equals B times C. It just looks real terrible. This KW is weird though. Look at your tiny table. KW is a constant. It is the ionization constant of water. Backside, left side, find KW. Circle, star, highlight KW. Backside, left side, towards the top. It looks awful. Libby, Gabriel. That's how I started my name right here.
Right side, left side.
Towards the top, KW. You should be circle, star, highlighting that KW so that you know where to find it next time. I want to demystify this number a little bit because this looks nasty. So KW is 1.00 times 10 to the negative 14 moles per liter squared, which just looks all kinds of awful. Let's demystify this for a second. How do we know those decimals? That's just really 1 times 10 to the negative 14. We've seen moles per liter. What is that the same as? Moles per liter. Yeah, it's our molarity. So this is really molarity squared, which makes sense, because I'm going to multiply 2 different molarities, 2 concentrations, to get this number. Ignore this guy for now. This is the number that I want to use for KW. So then, we need to solve for hydroxide. Take 10 seconds. Isolate hydroxide. This should feel cute. It looks nasty, but it should feel cute. Isolate hydroxide. You're like, looks a little strange. It works, actually not very hard. That's like hydroxide. The gas all this stuff. To isolate hydroxide, can we hear from?
Eric.
Alright, we're isolating hydroxide. What does that look like? What needs to move? What needs to move? What do I do with it? One side or both sides?
One side.
Both sides. Ta-da. So then hydroxide equals KW divided by hydrogen. Go ahead and plug in your values and solve. You get 1 point stuff with an E in it.
What's the 1 times 10, right? What's the exponent?
Negative 14.